In this Q&A video, we'll be answering the question, do I need to install a double pole RCD to protect an EV charge point? This question relates to the recent video that I made on the new consumer unit from Luden, so please do go and check that video out after this one. But what's prompted this question about double pole RCDs? Well, we get asked quite a lot about this on our channel when the subject of EV chargers comes up, and we've also heard reports that even some wholesalers aren't familiar with what a double pole RCBO is. So let's try and clear it up a bit. First of all, we're going to turn to the regulation in question that's causing the fuss. We'll find it in section 722, which is concerned with electric vehicle charging installations, and specifically regulation 722.531.3.1. Now, I'm reading this from the second amendment to the 18th edition of BS 7671, and it says, RCDs shall disconnect all live conductors. Gloriously simple. So surely in a single phase system, a single pole device will suffice as it disconnects the live conductor. But hang on a moment, why does it say live conductors, plural? Obviously it must be referring to three-phase systems where we need to disconnect all three phases. Is that right? No, this is where we need to be really careful about how we read and apply the regulations. Let's look at it again. It says all live conductors, and if we turn to the definitions section of BS 7671, the definition for live conductor sends us to live part, where we read, a conductor or conductive part intended to be energised in normal use, including a neutral conductor, but by convention, not a PEN conductor. So in a single phase supply for an EV charge point, we would need to install RCD protection that disconnects the line and the neutral. Generally speaking, we're moving away from split load boards that have an RCCB protecting several circuits, but in principle, as long as this wasn't a type AC RCD and the other requirements of section 722 were met, then this would be an acceptable device to use. For more information on the different types of RCD and EV installations, please check out the free accredited training modules that we've made on these subjects. They count towards your annual CPD requirement and can be accessed via the links in the description below. What about if we're using an RCBO to protect our EV charge point? How can we tell if the device is acceptable? Well, first of all, there's the manufacturer's data to consider, but often you can tell just by looking at the symbols and diagrams on the devices. First of all, if we look at the diagram on this other device, you can see that it shows the incoming line conductor going through a little bump and then a square and then a switch contact with an X on the other side. So let's break that down a little bit. The bump means the device has magnetic overcurrent protection, good for protecting against fault current. The square indicates thermal overcurrent protection, good for protecting against overload. The switch contact indicates that the line connection will be disconnected if there's a fault or the switch on the front is operated, and the X indicates that the disconnection mechanism inside can withstand breaking and making fault current. It then carries on up through a loop and out to the circuit and the load. Now let's consider the neutral conductor for this device. Can you see it just comes in through that loop and then off to the load? That loop represents a current transformer, which is how the device looks for high impedance earth faults. Again, check out our free training module for more information. However, what's really clearly missing from here is any form of switching device in the neutral connection. Therefore, when this device trips, it leaves the neutral connected. In many situations, this is not a problem. Think of all the thousands of single pole MCBs you've installed over the years that leave the neutral connected when a fault occurs. However, if this device is used to protect an EV charge point, then it doesn't comply with regulation 722.531.3.1. Now what about this device? It's the same width as the single pole RCBO we just looked at, so will this be acceptable? Well, again, looking at the diagram on the front here, you can see that the line conductor is very similar to the previous one. We've got the same symbols along its length, but turning our attention to the neutral conductor, you can see that now it passes through a switch as well before it goes off through the current transformer and off into the circuit and load. You'll also notice that there's this tiny dashed line connecting the two switches together, so that when one contact is operated, the other is too, meaning that in the event of a fault, all the live conductors, that's line and neutral, in this case are disconnected. It is just worth noting that there's no overcurrent monitoring on the neutral conductor in this device. You see there's no bump or square in the incoming connection there. It isn't needed because that's all taken care of and monitored on the line connection, so it would be a bit redundant. So it's not like a double pole MCB that would monitor both the line and neutral for overcurrent. So sometimes you may hear this referred to as single pole with neutral switching or double pole. But either way, this RCBO would be suitable to disconnect all live conductors if used to protect an EV charge point. So there we go. That's why it's really important to make sure that our RCD protection is disconnecting all live conductors, and also how to tell if a device is suitable or not. Of course, there's lots more to consider for both RCDs and EV charger installation, so please keep your knowledge refreshed and up to date by looking at our free training modules that we mentioned earlier. But as always, we want to hear from you. Are you installing EV charge points? Were you aware that the RCD protection needed to disconnect the neutral too? Whatever your thoughts and questions, please leave them in the comments section below, and as always, thank you very much for watching.